Ciao, mi chiamo Michele, I'm an Italian physicist and I work here at FERMI, which is the unique fully CD-free electron laser now active in the world, and so probably it is also the best one. I started working as a master student with tabletop laser, so with very compact experimental setup, and as an optical physicist, and finally ended up with working with machines like this, which are a little bit bigger. Here I work in the PADReS group. What does PADReS stands for? It stands for Photon Analysis Delivery and Reduction System. We are a support group, which means that our primary aim is not doing experiment, but making them possible, and we take care of the diagnostics of the light and most of all of the optic. Here I work in many different places, so let's quickly have a look at what they are. That's my desk. This is where the story of the optic starts. Here we do the design and the simulation, the data analysis, and the interaction with the manufacturer. It's a very funny place, especially for the colleagues, but we have more exciting ones. This is the Metrology lab. It is a little bit like the nursery of the optics. When the optics are born, we take them here, we see if they are in good shape, we measure them, we use interferometers, profilometers, we use visible light instruments to investigate what we'll have to work with X-ray light. I like this thing. This is the control room. It's a cozy place full of huge monitors. Here it's where the story of photons and electrons starts. I don't really work here, but I always get in touch with this place to coordinate with for all the operations that we do during the beam times. What first attracted me to this field of research is the fact that we do simple things in a very complicated way. For instance, consider focusing the light. With visible light, you do with a pair of glasses that you can bring in your nose. But when you come at the X-rays, you have that piece, which is the equivalent of my pair of glasses. Because around each piece of technology, there is a lot of knowledge and a lot of more technology. For instance, in the case of mirrors, you need to know about the roughness on the nano scale of the surface. Then you need to take care of the kids electric motors controlling the curvature, and then you need to measure the waveform which is coming out from all this, and you need to put all of this in this huge chamber of steel, and you need to develop the control of all of that remotely, because it is just like the Mars rover. It is doing something simple as moving, grabbing some stones, taking some picture, but the knowledge and technology to do this and to gain more knowledge and more technology is huge, and this really fascinated me. What inspires me in doing my job is, well, not money. Actually, there are two things that I do love what I do, and they are: the first, when some group achieves some great results, I know that that is possible and was possible because also what I did. I know that behind the group were my solutions, and if these solutions are found interesting from somewhere else in the world, they will ask for them. And here we are at the second point. I do love conferences. I do love attending conferences, meeting new people, being part of the community, telling what I did, listening at what the others did, and from this I really draw new ideas and new inspiration and new motivation for my job. The advice I would give to someone entering the world of large facilities is go for it. They're a crazy environment and you will enjoy it. But remember, large facilities can be very time consuming. So always keep in mind what you can give to science and what science can give you back. Also, find the right people. People you can learn from and people you like to work with. Because remember, science facilities are wonderful creations, but the most wonderful creations is your career, your life. So as an optical physicist, I tell you, don't be focused on your sample only, be focused mostly on you. There are two best things I love about working at the FEL source facility. The first one is the fact that you are doing something that no one is doing or very few people are doing in the world, and that your solutions are probably the new solutions and can be of interest to the others. The second is that you need a lot of teamwork, because in a FEL, you have many groups which are working together or at the same time. The meshing group, the laser group, the photon transfer group, the beamline scientist, all these must coordinate to achieve the same result. And so you learn a lot about being in a unique process. The community of the light sources for sure is terrifying and interesting, as we have at least 2 comics magazines who told stories about us. And if you want to know how we are seen from the outside, that's the answer. We are pictured as a quite variegated and strange fauna. Aside from this, I do think that the light sources community is great and very interesting, and that being part of the community is one of the most important and exciting things here.